Hi. Hi everyone. Welcome to our second lecture. And for this lecture, we will be beginning with mathematical models. So this is our second lecture for calculus 1, 2, and 3. So here we will be focusing on, questions, that contains everything from this chapter, and we're going to do one whole example, and as we go along we're going to do every single step, and as we go along with each and every step we are going to also explain what is going on with the equation, right? So chapter that we're doing is mathematical models, catalog of functional functions, essential functions, my bad. So remember, um, the book was, I have already stated, but I'm going to state that again. Don't worry about it. If you have not seen the introduction video, I'm going to make sure that I, mention it again. But make sure you see the introduction video to ensure what book we're using. All right, let's begin. So we'll do one master question, and then as we go along, we are going to, you know, as we go along, we are going to explain what's going on. You can see the screen, right? You can see the screen. Master question. I think what I will do is switch off night light. I hope now you guys can see a bit better. Yeah, increase the brightness so you guys can see. All right. The first question, we have f of x is equal to root of x plus 4 by 1 minus sine x. So we're going to do everything from this question. So first of all, step 1, we want to classify the function. So what does classifying the function mean? Typically, we want to observe what type of function is this, what type of domain is this, what exists, because each of the type of equation that exists inside the function will have the type of rule that they are going to portray on, right? So each of the equation will have each of the domain, each of the behavior, each of the derivatives, each of how they solute to a certain problem, right? So we're going to break down this equation. So break down the equation. So we have what do we have? We have root of x plus 4. So that is a root equation, right? So that is a root equation. We have 1, obviously that's a value. Sine x, we have a trigonometric. We have a trigonometric, and the fraction itself, the entire fraction. So it's rational, right? It's a fraction equation, right? Cool. So we have a root equation, we have a value, we have a sign, and we have a fraction. So this is what you call a composite function. Composite function contains of any algebraic equations, any algebraic strategy, like you have the addition, then you have the division, then you have the subtraction, and you also have a trigonometric, which is specifically the sine angle. Cool. Step 2, now you're going to calculate your domain. So calculate domain. You're going to understand where your x values lie. So you're going to observe where x values lie for each of the equations. So where are the x equations existing? So we have root of x plus 4 and sine of x, right? We have root of x plus 4 and sine of x. Now, what we're going to do to calculate the domain, we have root of x plus 4 is less greater than or equal to 0. This always must be the case, right? So obviously root of x plus 4 must be greater than or equal to 0. Here in this case, you can for now say that x plus 4 is equal to 0. You can say that is equal to 0. So x is minus 4. So make sure that it always ends up x is greater than or equal to minus 4. However, for the denominator, you cannot have 0. Sine of x, so 1 minus sine x must not equal 0, because if it does equal 0, then this means that it ends up as what you call the zero error. And having zero error would obviously lead to inconsistency, so which means you're not going to get the values, correct? So for the numerator, you cannot have 0. I mean, you can, obviously, but make sure that it's greater than or equal to 0, because you're not only going, but like your bare minimum value must be minus 4. That's a domain for the numerator that has x in it. This cannot have 1 then. Sine x cannot be 1. Now, when are the times that it ends up as 1? So let's see. I'm just going to use a little bit of Google. Um, when angles output, when angles in sine output as 1. Okay. So at pi by 2. So if sine x must not equal 1, then your x should not equal pi by 2. And it should not equal pi by 2. What you're going to do is, instead of pi by 2, you want to add that. You want to like shift it, like you want to tilt it to pi k. Because if you have just pi by 2, that outputs 1. But pi by 2 plus 2 pi k, it goes one more cycle, right? It goes one whole cycle and then one whole cycle. So it doesn't end up as 1. And if it does end up as 1, what happens is obviously you end up where you call zero error. You can't have zero error here. You're gonna have pi by 2 plus 2 pi k. So two things to consider. Your final domain should be x greater than or equal to minus 4, and x shall equal whatever the pi by 2 plus 2 pi k. 2 pi k. Pi by 2 plus 2 pi k, which means you're going 3 by 2 cycles. 3 pi by 2 cycle, right? If k is 1, then you're going obviously 2 pi times pi, which is 2 pi square by 2, which is pi square. One more, one and a half cycle, one and a half cycle, one and a half cycle. You're not going one whole cycle, because if you have half a cycle, then it ends up 1, and you don't want to have 1, right? Cool. So we got our domain. So first up, you need to calculate your domain. So domain first. So here, step 1, we calculated the domain. Now we need to observe the intercept. Step 2, step 2 or step 3? 3. Step 1, and this is step 1 and step 2. Step 3, observe the y-intercept. Let's go back to your equation. Sorry, not y-intercept, x-intercept. X-intercept only works is if your equation, like you can, it the only way you actually calculate the x-intercept is when whatever the function you're given, you have to set that as equal to 0. Right? You have to set that as equal to 0. Y-intercept, however, works when you set your x to 0. You have to set your x to 0, you get y-intercept. You have to set your f of x to 0, you get x-intercept. So x-intercept works if you're, so x-intercept, I'm just going to write it in red color. So x-intercept, f of x is equal to 0. Y-intercept, x is equal to 0. And so therefore we're going to have, if f of x, so if to calculate the f of x, what was the equation? Root of x plus 4 by 1 minus sine of x is equal to 0. Obviously you can do that. So root of x plus 4 is equal to 0, x plus 4 is equal to 0, x is equal to minus 4. This is your x-intercept. This is your x-intercept. Y-intercept, where x is equal to 0, then I'm going to have root 4 by 1 minus sine 0. So root 4 by 1, which is root 4 is equal to 2. Sine 0 is 0. 1 minus 0 is 1. Right? Cool. Now, we got the x-intercept, we got the y-intercept, we got the domain. So far, what did we have? So far, I'm just going to write so far, we got the domain where x is greater than or equal to minus 4, right? And your sine of x must be, oh, sorry, uh, not sine of x, x. Your x must be equal to pi by 2 plus 1 whole cycle. Half a cycle plus 1 whole cycle. If k is 1, then 1 whole cycle, k is 2, then 2 whole cycle, right? So that's 1. 2, we got the x-intercept. For when f of x is equal to 0, you get your x as minus 4, and your y-intercept for when your x is 0, y is 2. Cool? Now we want a linear model. The linear model general equation is the f of x is equal to f of 0 plus f prime of 0 x plus f prime prime of 0 x squared, f prime prime of 0 x cubed, so on and so forth. Here we only need the first derivative because we're trying, obviously, this is, first of all, this is the first calculus model. We don't want to go, to the power 2, to the power 3, to the power 4, and so on and so forth. Second of all, we only have one value. We don't have a second derivative equation here. We only have one type of equation, which is obviously the first equation. So now if we calculate the linear model, it's going to end up as f of x is approximately equal to f of x is equal to f of 0 plus f prime of 0 x plus f prime prime of 0 x squared. We don't want to go that far, and so on, so on, so on. But we only stay with the first derivative. So that is linearization. That is what we call linearization. We want to add the original equation plus the derivative of the original equation. Right? So that's typical. You probably did this in high school. And now we calculate the slope. When you look at the f of x equation, it is what? Root of x plus 4 by 1 minus sine of x. Forget about what is given to you. Observe that this f of x is in the format of u by v. Right? This equation is in the format of, so this equation is in the format of u by v. And so general equation, the general fraction equation for derivative, you're going to have f prime of x being u prime of v minus vu prime divided by v square. Your u is what? U is root of x plus 4. So I'm going to write x plus 4 to the power half. So half x plus 4 minus half. And oh, this shouldn't be uv prime. This should be, sorry, this shouldn't be vu prime. This should be uv prime. V here is 1 minus sine x. So sine x is cosine of x. So minus sine of x would be minus cosine of x. Eh? So V prime would be minus cosine of x. So f prime of x is equal to half x plus 4 to the power minus half 1 minus sine of x minus, just going to move that to the left, minus, I'm going to put a bracket here, 2. U is x plus 4 to the power half minus cosine of x divided by v is 1 minus sine x whole square. So this is 1 minus 2 sine x plus sine square x. So this will be 1 minus 2 sine x plus sine square of x. And then you're going to do the differentiation. I'm going to make it easy actually. So we have f prime of x is equal to half 1 by x plus 4 to the power half. So this will be half divided by x plus 4 to the power half. We have half divided by x plus 4 to the power half, 1 minus sine x minus root of x plus 4 minus cosine of x divided by 1 minus 2 sine of x plus sine square of x, right? Cool. So this is your f prime of x. So this is your f prime of x. And you know your linear function equation. You know the y is equal to mx plus b. This m is your gradient. So typically, this guy right here, that whole equation, this whole equation is your gradient, right? Now, I know there is f prime of x and b being f of x. So here, m is your f prime of 0, b is your f of 0. What was f prime of 0? Actually, we can get f prime of 0. F prime of 0, you're going to replace all the x values with 0. So you're going to have half by 2, so that is 1/4, right? So you're going to have, I think, f prime of x is equal to 1/4. 1 minus sine of 0, so that is 1. I'm going to put a bracket, it makes it easier. Minus root of 4 is 2. Minus cosine of 0 is 1. Divided by 1 minus sine of 0 is 0. So 1 minus 0 plus 0, which is 1. F prime of 0 being 1/4 minus 2 by 1. Is it minus? No, minus cosine of 0 is minus 1. Minus, because cosine of 0 is 1, and 1, so minus times cosine of 0, which is minus times 1, which is minus 1, but we have a minus in the middle, so it's going to be plus 1, so 2. So 1 by 4 plus 2, 1 by 4 plus 2, 2 is simply 8 by 4, so 9 by 4 by 1, which is equal to 9 by 4. So you got your f prime of x. Now f of 0, we got f of 0. Remember, we got f of 0. Where is it? F of 0 is 2. So y is written in the format of mx plus b, or y is equal to f prime of 0 x plus f of 0, where y is equal to 9 by 4x plus 2. So now you have your whole equation, right? Cool. So now you have the y equation, you have your f prime of 0, f prime 0 of x, you have f0 of x, get an idea and whatever. Cool. To observe the behavior of each of the equations that we have, so if you look at the sine will create this graph, but because you have 1 minus sine of x, it's going to create to the right. So it's going to create an asymptote. It's going to, so whatever the graph you have here, it's going to move. No, 1. So it's going to move 1 to the left. Is it 1 to the left? So sine of 0 is 0, then 1 minus 0. No, it's going to move to the right. So 1 minus sine of x. So if it starts from 0, sine 0 is 0. But if I have 1 minus sine of 0, it's going to start from 1. So you're going to have start so instead of here, so when you look at the graph usually, it's going to be like that. But you're not going to see like that. You're going to see it continues and then it's going to come here, then go up. You're going to see a flat line on the in the 0 point instead of starting point, right? So that's the behavior of the sine of x, specifically 1 minus sine of x, and obviously root of x plus 4. Obviously, you know that there is a power law, right? So root of x plus 4 being x plus 4 to the power half. You get your equation, so n is half, so you know that that's typically square root, right? So that marks the end of section 1.2. So that marks the end of section 1.2. Hopefully you understood. Hopefully you know what's going on. And yeah,